physical method of microbial control kill or remove the microbes without chemical, using heat, filtration, radiation, or drying. So these methods are used for sterilization in healthcare, labs, and industry.
For moist heat, boiling water or flowing steam destroys most bacteria, viruses, and fungi. However, it does not reliably kill endospores. The second method for moist heat, autoclaving, uses steam under pressure to reach 121 degrees Celsius or higher for sterilization. It kills all types of microbes, including resistant spores.
Another is pasteurization, the mild heating of milk and other materials to kill particular spoilage organisms or pathogens. It does not, however, kill all organisms.
The most common technique is direct flaming, which involves passing metal instruments such as inoculating loops or needles through an open flame, which then instantly incinerates bacteria and other microbes on the surface. Another is incineration. This method uses extremely high temperatures to completely destroy all microorganisms, even endospores, which are among the most resistant forms of life. Traditionally, incineration involves open flames, like those seen in waste disposal or burning contaminated materials. But in today's laboratory, electric incinerators are often used, as these devices allow precise temperature control and minimize the risk of aerosol generation, making them safer and more efficient.
Water sterilization is a method that uses dry heat to kill microorganisms. Items are placed in an oven at around 160 to 170 degrees Celsius for 2 to 3 hours. It works well for things like glassware, metal tools, and powders that can handle high heat. Filtration, on the other hand, removes microorganisms by passing liquids or gases through a filter. It's great for sterilizing heat-sensitive substances like antibiotics, enzymes, and vaccines.
Refrigeration slows microbial growth by reducing enzyme activity and metabolism. Most bacteria stop growing at temperatures below 5 degrees Celsius, making it an effective way to preserve food for short periods. However, psychotrophs can still grow, so it does not sterilize. Deep freezing preserves microbes by stopping all cellular metabolism. Temperatures around negative 50 degrees Celsius to negative 95 degrees Celsius can keep bacteria and viruses viable for years. This method is commonly used in labs for long-term storage of microbial cultures.
Lyophilization is a freeze-drying process used to remove water from a product after it is frozen, allowing for preservation without the use of heat. This method is commonly used in pharmaceuticals and biotechnology to increase the shelf life of sensitive substances.
Desiccation is an extreme drying process. Microorganisms cannot grow or divide when desiccated, but can survive for certain periods. However, it does not guarantee complete sterilization because as water becomes available, microorganisms start to grow again. Osmotic pressure is the force exerted on a solution to prevent the solvent from passing through a semi-permeable membrane. Molds and yeast may withstand higher osmotic pressure, while 𝒍𝒊𝒂𝒂 species are fairly resistant.
Ionizing radiation is a microbial control method that uses high-energy waves, such as gamma rays or X-rays, to destroy microbial DNA and cellular structures. It effectively sterilizes medical equipment, pharmaceuticals, and food products. Non-ionizing radiation is a microbial control method that uses lower energy waves, such as ultraviolet light, to damage microbial DNA and inhibit replication. It is primarily used for disinfecting air, water, and surface.
For microbial control at home, how effective are they? About 99.9% of microbial populations can be reduced using physical methods, and other methods include autoclaving and UV radiation. So why does it matter? Physical methods of microbial control are crucial because they effectively eliminate microorganisms. These methods effectively reduce or eliminate harmful microorganisms, preventing disease transmission and food spoilage. So common practices help prevent food poisoning and infections. They help maintain hygiene without chemicals, and they are able to provide overall protection to vulnerable household members. A quick tip: Use heat, cold, and drying intentionally in daily routines, especially in food handling and cleaning of high-touch surfaces in the household.
Here are examples of physical methods to practice microbial control at home. First, moist heat, such as boiling drinking water and kitchen utensils to destroy microbes. Dry heat, sun-dry pillows and blankets to reduce bacteria and odors. Refrigeration, store foods at a temperature of 47 degrees Celsius to slow down spoilage. And freezing, keep items below 0 degrees Celsius to stop microbial activity.
Next would be the osmotic pressure. Preserve food like fish or fruits by adding salt or sugar to prevent microbial growth. Desiccation, let wash dishes and utensils dry completely to avoid bacteria. Liquid filtration, use clean water filters for drinking water to trap microbes. Lastly, we have air filtration, used to purifies to keep air free from airborne microbes and dust.
I lost your track into the universe, a place to cry, to be devoured by